This is AWR Microwave Office tutorial series. In this video, we will simulate a real or non-ideal operational amplifier. And in order to do this, we need to model an op-amp with non-ideal characteristics. We'll learn how to do that in this video. So let's get started. Next, we'll open AWR. And in the first step, we will model non-real amplifier, which we can easily do by assigning Spice model provided by manufacturer. I've already downloaded the model for you, which you can find in the same link given in the description. So next we'll import that model into the AWR. To do that, we'll just go to netlist, right click and click over import netlist. And here we have to select the model which we have downloaded. So I've saved that model in tutorial 10. So we'll just go there. And this is the model we are going to use for UA471 amplifier. We'll just select that and click over add button. Now here it is asking which file it is. Is it a pSpice model or HSpice model or any of the model provided in the list? So as per manufacturer, it is a pSpice file. We'll just select that pSpice files and click over OK button. Now we can clearly see the model. And here we can see it has 5 pins: non-inverting input, inverting input, positive power supply, negative power supply and output. The numbering of these pins you can find somewhere here. So it is in order like 1, 2, 3, 4, 5. If you'll open that file in Notepad, then you can find these numbering here. So this is a sort of some import here and there, but we don't need to worry about that because Spice model will take care of that when we'll assign that to a subcircuit. And here we'll find all the parameters which will be assigned automatically as soon as we'll assign this model. In order to assign this to a subcircuit, we have to create new schematic. So we'll just right click over this circuit schematic, click over new schematic. I'm going to name that non-ideal amplifier and click over OK button. Now here we have to place a subcircuit block, which you can directly place from here. Now as soon as you'll click over this subcircuit icon, so it will automatically detect the list of imported netlists. So as of now, we have only one imported netlist, which is for UA741 and it has 5 ports. So we'll just select it and click over OK. And we'll place it somewhere here. So as of now, you can see there is no naming provided in this symbol. Now to assign the correct symbol of an amplifier to this, we have to again select the symbol, right click, go to properties. From here you have to select the symbol tab and we'll scroll down for op-amp 5-pin apac.syf file. Alright, so here we can see it will be like that, which has 5 terminal as our symbol. So we'll just click over OK. And now we can clearly see the correct pins have been assigned. So 2 is inverting terminal, 1 is non-inverting, and then we have 3 will be the positive power supply, 4 will be the negative, and 5 is the output of amplifier. Now in the next step of this video, we are going to create the schematic. So before starting that, since this is a non-ideal amplifier and we are going to use it as a non-inverting amplifier, so that means we have to tie all the unused terminals to ground. If it is an ideal amplifier, then we can leave it unconnected. But in this case, since we are creating a non-ideal or real amplifier, we have to tie it to ground. Next, we have to add a DC VSS. To do that, we'll just go to library by hitting Ctrl L on our keyboard and make sure you have selected DC VSS, which is for DC sweep. We'll just select it, place it somewhere here. I'm going to connect it and then place another ground here. In our case, the values of V start, stop and step will be, so for V start, I'm going to start it from -1 millivolt. To do that, we have to press -1 E -3 and stop will be 1 millivolt, 1 E -3 and step size will be 10 microvolt, then 10 E -6. And next we have to add negative and positive power supply. Since the input of this amplifier is swinging between negative and positive voltage, so we have to add both here. And to do that, I'm not going to add power supplies directly on these terminals, which will make this schematic a bit bulky. To do that, I'm firstly going to place the DC supplies. So again, go back to library, and here we'll type DC voltage source. Okay, we'll place it somewhere here. All right, we'll just copy it, place another one here, and one will be, let's say, plus 10 volt and another will be minus 10. Now to connect the terminals of this amplifier to these supplies, we are going to use another symbol, which is the naming connector or named connector. So we'll place it from the library. Let's type ancon. Okay, we'll place it here. We'll copy it and place it here. Let's name this positive VCC, and this will be the negative VCC or NVCC. Now we'll simply copy these and place on our terminals. So this will be the positive VCC and this will be the negative VCC. To rotate the component, you have to just right click on your mouse, and at the output of this amplifier, we have to add a 10 kilo ohm resistive load. So let's go back to library, search for closed form resistor. We'll place it here, connect it to another ground. Now to measure the output voltage, we are going to add a V meter here. Again, go back to library and search for V meter. I will place it parallel to this resistor. And these should be again connected to ground. Alright, so as you can see, our schematic is ready. Now in the next step of this video, we are going to create a new graph. To do that, we'll just go to graph. In the project window, right click and click over new graph. I'm going to name it V in versus V out. And this will be another rectangular graph, and click over create button. Now we are going to add the measurements like we have already done in previous tutorials. So right click, go to add new measurements, go to nonlinear and voltage measurement, since we are going to plot V in versus V out. And here we have to select VDC. Make sure the data source should be selected as the schematic name, and measurement component will be the output voltage. So we'll just click over these three dots, select the meter and click over OK. Now we'll simply apply and click over OK button. And at last, after setting up all the measurements, we have to just run the simulation. So as soon as we'll do that, we get a response from this amplifier, and we can clearly see the operating range of this amplifier is quite a bit low in terms of voltage. And after the certain voltage, the amplifier will get saturated. All right. And this is the input voltage we are providing from minus 1 millivolt to 1 millivolt, and we are getting output swing from minus 20 millivolt to 20 millivolt approximately. So we can simply place marker at this point and this point and see after these points, after which voltages the amplifier is getting saturated. So to add the marker, right click and click over add marker. We'll place one marker here and we'll add another marker here. So as per these markers, we can clearly see the operational range of this amplifier is very tiny. All right. So that's it for this video. In the next video, we'll talk about inverting amplifiers with ideal and non-ideal op amps. So let's save this project. To do that, we'll go to File and click over Save Project. I'm going to save it on desktop. Let's name this project a non-ideal, non-inverting amplifier and click over Save button. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.